Good morning. We're starting to look at our next set of quadratic notes, and this should be in the notes packet that you received before Christmas break on the days of final exams. So notice that you're starting off being given a list of quadratic equations, and you're asked to do a couple of things with those. And so first off, I want to remind you that the standard form of a quadratic is y equals ax squared plus bx plus c. And we do have only one condition on that. A cannot be 0. And the reason is because if A were 0, you would not have that quadratic term. So it would either be a linear or just a constant horizontal line. So as you look down through here, I'm going to have you actually pause the video, and then you're going to be asked some questions. You're going to be looking for identifying A, B, and C, and then you're going to find the axis of symmetry with those. And, you know, there's several different ways that we can do that to start off with, and then we're going to see what you can come up with. So in problem number 1 here, A is 1, B is -3, and C is -18. So at this point, there's two different ways that you know how to find the axis of symmetry. One is you can complete the square and write it in vertex form. So that's one strategy. You can complete the square and write it in vertex form. And your second method is find the middle of the x-intercepts. Now, we also know that not all of our x-intercepts here are easily found, and so sometimes that second strategy isn't useful for us. So let's take just a moment and look at problem number 1 here. So as I think about problem number 1, I'm going to first test out to see if this factors. So let's see, this should factor into x minus 6 and x plus 3. I use zero product property and set each factor equal to 0, and I get x equals 6 and x equals -3. So if I think about what the middle of those would be, so I know that these are 9 units apart, so halfway between those would be a distance of 9/2. So I can go to -3 and I go right 9/2, or I go to 6 and go left 9/2. Either way, I can see my axis of symmetry is going to be 3/2. Okay, so with that, I could complete the square. So I could take y equals, I don't have to worry about factoring here, x squared minus 3x plus a blank minus 18, and I'm going to end up balancing that. So let me erase this plus. Let me do minus a blank. In order to complete the square, I know that I'm looking for making this into a PST, so I like to think backwards. So I'll have x and x, so I know to get -3 I would need -3/2 and -3/2, both those would be minus, so that means I'm going to add 3/4. I turn around and balance that by subtracting 3/4, so x minus 3/2 squared minus 18 and 3/4, and it really doesn't matter what that is, that's the y-coordinate of your vertex, but I do see that, again, I'm agreeing that the axis of symmetry here is 3/2. And so you're going to get some time to work on those and state the axis of symmetry. So I'm going to label these 2, 3, 4, 5. So you've got 2, 3, 4, and 5 to work there, and the video is then going to ask you what those axes of symmetry are. And the big thing that you want to do is you want to try to draw a conclusion here. What do you notice about the axis of symmetry when you compare it to A, B, and C? So that's what you want to make sure that you're really looking at. So hopefully you've had a chance to find all the axes of symmetry here. So we've got x equals -5/2, 5/4, x equals 5/6, and x equals -7/12. And I've already mentioned to you that here's the part that we're really looking at. What do you notice about the axis of symmetry when you compare it to the values of A, B, and C? Well, hopefully you saw that the numerator corresponds to b. So notice our numerator here is -7, b is 7. 5, b is -5. 5, b is -5, and so on. So actually, we would take the opposite of b if we want to try to find our axis of symmetry, and have it be divided by, and again, let's look at our denominators. We've got 12, 6, 4, 2. Think about how those relate to A, B, and C. It's actually over 2A. Which means now you can actually add a third way to finding your axis of symmetry. We already had up here, you can complete the square and get it in vertex form. It's the middle of your x-intercepts, but now we can add to that 3. Our axis of symmetry can be found by taking -b over 2a. And remember, that's also the x value of your vertex. All right, let's go ahead and turn the page. So as we're looking toward ways to solve a quadratic, we have a few different ways that we've already established on how to solve a quadratic. One way is we can graph. And solve means set an equal to 0. We can graph it. Now there are some disadvantages to that. Not every quadratic has x-intercepts, so that's a downside. We can't find the x-intercepts of those, and sometimes you would have to have a calculator for that. Okay, so we could graph. Method 2, we could extract the square root. And in order for it to be in that form, you're going to have no linear term. So, for example, you would need, I'm going to set this equal to 0, a problem like 2 times x minus 5 squared minus 6, we'll say. So you could add 6, divide by 2, and then take the square root of both sides. Or you might have a problem like 3x squared minus 12, let's say. You would add 12, divide by 3, and then take the square root. So as you can see, there's no linear term there. Okay, 3, you could always factor. We like to factor. Factoring's easy. You're good at it. The disadvantage is you can't always use factoring. Okay, third or fourth method, we can complete the square. Now, what's good about completing the square? It always works. It always works. What's the disadvantage? It can be rather sticky sometimes. And our last method, quadratic formula, which we're going to take a look at more in just a moment. So other ways to solve, or other ways to ask you to solve, and you guys know these, we can find the roots, the zeros, the solutions, or the x-intercepts. All right, so today, for the rest of our video here, we're going to derive the quadratic formula. And so remember, you should be writing all of this down. You should definitely have this in your notes, because at some point you're going to be asked, where does the quadratic formula come from? And you should be able to answer that question. Where does the quadratic formula come from? And at this point you might have said, oh, my teacher in 7th grade taught me, it just told me that it works, and so it works. Well, there has to be a place that it comes from. And so we know what the quadratic formula is. You probably learned a little song to it. -b plus or minus the square root of b squared minus 4ac all over 2a. Personally, I like to write it as -b over 2a. Ooh, that should sound familiar to you with something we've just done today. And then over 2a. I like to break it apart, and you'll see why eventually. All right, so let's derive this quadratic formula. So I'm solving for x. And so in order to solve for x here, I'm going to go ahead and move c over. And I can see this is written in a form where I need to complete the square. So I want to get x by itself. So I'm going to try to write this in vertex form. So what I'm going to do is factor a out. B will become b over a. And I'm going to go ahead and put a plus a blank here. And I'm going to draw my arrow, because I know whatever goes in that blank has to be multiplied by a. And then I'm going to go ahead and balance it on the other side. Okay, now back to thinking backwards. We've done that a lot when we've completed a square. So what would give us b over a in the middle? If you were to factor this, what would give us b over a in the middle if we were to multiply everything out? Well, that would need to be b over 2a. Okay, that should make sense to you, and we'll talk more about that in just a second. So working backwards, that means that b squared over 4a squared is what I would need to put in the blank. Now I do need to balance, and that's being multiplied by a, and so I can reduce that fraction, which leads me to being balancing on the other side, b squared over 4a. All right, with the little manipulation, I'm going to write this as x plus b over 2a squared, and that should make sense to you. This is a transformation left, b over 2a, negative b over 2a. That's why negative b over 2a is your axis of symmetry that you just took a look at. On the left-hand side, I'm going to go ahead and get a common denominator. So I'll have b squared over 4a. And then I'll have, to get a common denominator, let's see, that's over 1. I would need to multiply 1 by 4a and c by 4a. Oh, getting closer there. So I can write that as b squared minus 4ac all over 4a. Some of that sound familiar with the quadratic formula? Let's now divide by a. So b squared minus 4ac all over 4a squared. Oh, sorry, you can't see what I was doing. I just divided by a. So now I would take the square root. I can't do anything with the numerator because that's subtraction in there, but in the denominator, the square root of 4 is 2, the square root of a squared is a, and on the right-hand side, the square root and the square cancel, but I am left with absolute value, which is super important here. And that's what gives us our two solutions, which means I know that I will have a piecewise. So the absolute value of x plus b over 2a will be x plus b over 2a if x is greater than or equal to negative b over 2a. And the opposite of that, which again, negative b over 2a, that's our axis of symmetry. At this time, I can write my two equations. I'm going to take the first piece of my piecewise and set it equal to what I have here. And I take the second piece of my piecewise and set it equal. Oops, I'm going to have to kind of cram it in here. Okay, so I solve for x. I get x equals negative b over 2a. That would be plus the square root of b squared minus 4ac all over 2a. Okay, that's half the quadratic formula. Now, if you remember anything about when we completed the square before break, we know that our two solutions of the quadratic turn out to be conjugates of each other. So with my first equation, I got negative b over 2a plus the square root of b squared minus 4ac all over 2a. My other solution will be negative b over 2a minus, that's the conjugate. And there are your two solutions. Notice a lot of times we write this as a single statement. I also see that it reveals the axis of symmetry. So if someone were to ask you, where does the quadratic formula come from? You would respond by saying, it comes from completing the square.